In this video, we're going to look at multiplying a binomial by its conjugate. So let's start out by looking at what is a conjugate. I have some examples of binomials over here. So we're going to write the conjugates of these binomials, and it's really easy. Basically, you're going to take the same terms. So this we have 3x plus 1, so I'm going to take the first term and the last term, and all I'm going to do is just change the sign. All right, so the conjugate of 3x plus 1 is 3x minus 1. Next problem, so 4w minus 18q. What's the conjugate? First term's the same, second term's the same, and I'm going to switch the sign. So the sign was a minus here. I'm going to switch that to a plus. All right, so what's the conjugate of a plus b? Yep, a minus b. And what's the conjugate of a minus b? Yeah, it's a plus b. So now we're going to look at what happens when we multiply these together. What happens when I take 3x minus 1 times 3x plus 1? What happens when I take 4w minus 18q times 4w plus 18q? Are there any patterns we can see that would help make multiplying something by its conjugate faster? All right, well, let's try it. So let's first look at 3x plus 1 times 3x minus 1. And in this first example, I'm going to use basically a distributing property. So we're going to take this 3x plus 1 and we're going to multiply it by 3x, this whole binomial. And then we're going to take this whole binomial times minus 1. In the second example, we're going to use the FOIL method, which some of you may be familiar with as well. All right, so we're going to take 3x plus 1 times 3x, and then we're going to take 3x plus 1 times negative 1. All right, so if I multiply this out, 3x times 3x and 3x times 1, what do we get here? 9x squared plus 3x. And then I take negative 1 times these things, these two terms, and we get negative 3x minus 1. So look what happens here. We have a positive 3x and a negative 3x. Those are going to add to be 0, and we just end up with 9x squared minus 1. All right, let's try this one over here. So we're going to do first, outside, inside, last. So 4w times 4w is 16w squared. 4w times 18q, let's see, 4 times 18 is 72, and then I'll just put these in alphabetical order, qw. And then negative 18q times 4w is negative 72 qw. Then last, we have negative 18q times positive 18q, which is negative 324q squared. All right, so this is our FOIL. First, outside, inside, last. And once again, we see that these two middle terms are going to add to be 0. And that will always be the case when you're multiplying something by its conjugate. The O plus the I is going to end up being 0. So our answer is 16w squared minus 324q squared. So in general, if I have a plus b times a minus b, we end up with a squared minus ab plus ab minus b squared, or a squared minus b squared, which is basically your first two terms multiplied together and your last two terms multiplied together. Where'd the OI go in the FOIL? Well, it added to be 0, and that only happens when you're multiplying something by its conjugate. All right, so you can kind of memorize, or not memorize, but internalize and understand why anything times its conjugate is just a squared minus b squared. Now this is going to come in handy when you get to do factoring. When we do factoring, we give you this a squared minus b squared, and you have to break it back apart. So recognizing a perfect square minus another perfect square is the product of two conjugates is going to be really important going forward when you learn how to factor. All right, let's practice a few of these. So here's some more examples. I think it'd be a great idea to pause the video and try these examples and then unpause the video when you're done to see how you did. All right, let's go through these. So first of all, I see these are conjugates, okay? Since I know they're conjugates, I know that middle term is going to drop out. So I'm just going to do the first two terms multiplied together and the last two terms multiplied together. But make sure you check that it's a conjugate. Make sure that you check the binomials are conjugates of each other. All right, next one. Are these conjugates? Yep, 3 minus 6y, 3 plus 6y. So I know it's just going to be the first two terms multiplied together and the last two terms multiplied together. That's my answer. All right, next one. Are these conjugates? 10x plus 1/3 y and 10x minus 1/3 y? Yep. Okay, so I'm going to do the first and the last. So I get 10x times 10x is 100x squared. 1/3 y times negative 1/3 y is negative 1/9 y squared. So notice these answers are all binomials. All right, because the middle term is dropping out. And notice that the terms of all of these binomials in these answers are perfect squares. That's a perfect square. That's a perfect square. 3 times 3, 6y times 6y. That's going to come in super handy when you learn how to factor. All right, let's look at this one. Are those conjugates? 1/2 x plus 1/5, 1/2 x plus 1/5. No, those are not conjugates, okay? So we can't just do the first and the last. Now we got to do the first, outside, inside, last. And as a matter of fact, you may recognize this as the square of two binomials, which you could use that formula that you may have learned before. A plus b squared is a squared plus 2ab plus b squared. That's the situation we have right here. Let's go ahead and FOIL this out, and then we'll show how it meets that formula. So we have first, outside, inside, and last. And then those middle terms are going to combine. 1/10 plus 1/10 is 2/10 or 1/5. All right, so notice that this middle term is 2 times a times b. All right, the 2's cancel, and I end up with 1/5 x. That's that 2ab term right there. Okay, so we have a squared plus 2ab plus b squared. All right, hopefully this helps you learn some shortcuts for multiplying a binomial. Multiplying binomials, in this case, make sure that they're conjugates of each other, and if they are conjugates, the multiplying becomes very easy because those two middle terms will end up adding to be 0.